Jealousy, everybody. This video, I'm going to be talking about Chapter 2, Section 5, so 2.5. It is all about rational functions, and hopefully you remember your rational function parent graph. Yay! Rational function parent graph! Woo! Yay! Everybody claps, everybody has a good time! Yay! Okay, and now, all we are going to be doing is graphing different types of rational functions. So, one other type of rational function. Oh no, it's bendy. Maybe something like this. Yes. Rapidol. Oh, yeah. That's also a rational function. Okay, so they're going to get kind of crazy sometimes, but it'll be okay because we'll survive. So we're going to know how to graph them after watching this video and practicing, and lots of practicing and practicing and practicing and practicing. Yay, practice! Alright, so there are different parts of these functions that will change how the graph looks. First thing I'm going to talk about is horizontal asymptotes. If we are given the rational function ax to the n, where n is the highest degree in the numerator, over plus a bunch of junk, whatever that is, it doesn't matter. It will later, but it doesn't matter right now when you're talking about horizontal asymptotes. Over bx to the m, where m is the highest degree in the denominator. Okay, if n is greater than m, so if the degree on top is higher than the degree on bottom, no horizontal asymptote exists. That would be something like this, where we have the degree on top is x squared, the degree on bottom is x. I do not have a horizontal asymptote. And this one, I actually have an oblique asymptote, which we will talk about later, and we will have a good time with that. It's actually not too bad, so you guys will love it. I love it. It's my baby. If the degrees are equal, then a over b, the coefficients of those two things, are the horizontal asymptote. So here, I have 2x plus 3 to the first power, 3x to the first power. So since these are the highest powers, they are both the same, I'm going to take the coefficients, 2 over 3. That is my horizontal asymptote, so I have a horizontal asymptote at y equals 2/3, and then I can graph my function around it. Cool. That's awesome, Mr. Pike. I know, right? It's wonderful, right? Okay. If n is less than m, so if our degree on top is lower than our degree on bottom, for instance, the degree in the numerator is squared. The degree in the denominator is to the third power, so the degree in the denominator is larger. Therefore, my horizontal asymptote is y equals 0. Y equals 0. And you can see it gets closer and closer to 0 in both directions, but does not ever touch it. Yay! Happy day! Woo! We also have something that we have to think about. I just realized that I say K after everything. I'm probably going to keep doing it. Oh well. Either that or I say so. So here we go. We have something called vertical asymptotes. That is pretty much what it cannot cross going up and down, right? If it's vertical, it's going up and down. Ooh, sorry, I moved too fast. Going up and down. Vertical asymptotes would go something like that, but we cannot touch it. Vertical asymptotes you can definitely never touch. Horizontal asymptotes sometimes we can, but we'll get to that later. So with this, if you want to find the vertical asymptotes, remember that we can never divide by 0, but in order to find them, if I say that this is something I cannot have the denominator equal to 0, I know this will factor as x plus 2 and x minus 2 cannot equal 0. So I know that x cannot equal negative 2 and x cannot equal 2. Those would be my vertical asymptotes. So I have 1, 2, do-do-do-do-do, do-do-do-do-do, 1, 2, do-do-do-do-do, do-do-do-do-do. And my graph would do some crazy stuff around that. I don't know what it would actually do because I'm not going to graph that one. But we will in a little bit. Yay! I don't know why I just marked through it. But yay! Monkey, happy monkey, yay! Okay, here we go with our first example. Find the asymptotes, both horizontal and vertical, the intercepts, both the x-intercept and y-intercept, and graph this function. So I'm going to go ahead and just kind of write some things, just leave blanks. And those are just all of the things that I want to find. So if I'm looking for the horizontal asymptote, again, I remember my rules. I look at the exponent on the numerator. There isn't one. The one on the denominator is to the first power, so the one on the numerator is smaller than the one on the denominator. If you remember back from your rules that we just talked about, if you can look at your notes, remember you guys can read your notes, yeah. So if the degree on top is lower than the degree on bottom, y equals 0 is our horizontal asymptote. So yay, y equals 0 is our horizontal asymptote. So at 0, I'm just going to draw a dotted line that I can never touch. Nunca. For the vertical asymptote, I'm going to take the denominator and set it to 0. Oops. And x can never be negative 1. So at negative 1, I can never cross that line. Yay! For my x-intercept, if I set my y to 0, and I can multiply by x plus 1 on both sides, but really 0 times x plus 1 is just 0, so 0 equals 5, so there is no x-intercepts. Yay. Y-intercept, don't forget that you just substitute in a 0 for x, so you have h of 0 equals 5 over 0 plus 1, so my y-intercept will be 5. So 1, 2, 3, 4, 5. Cool. So I have my asymptotes, and I have 1 point on my graph. Well, what I'm going to do then, just to kind of check the points around it, because I don't know what it does on this side of the graph, whether it's above the horizontal asymptote or below the horizontal asymptote, is, well, if you're not really sure of how to graph things, you can always make a table and kind of substitute numbers in. So say I choose, what would be nice? Negative 6. Because then I would have Corey's trying to get in the room. Corey, you're not allowed in here. You smell bad. So you have negative 6 plus 1 would be 5 over negative 5, which is just negative 1. So I have the point in negative 6. 1, 2, 3, 4, 5, 6, negative 1. So it'll go somewhere over there. I'll see what happens at 2. At 2, if I substitute that in my function, oops, sorry, I mean negative 2. 5 over negative 2 plus 1 equals 5 over negative 1, which is just negative 5. So negative 2, negative 5. So probably my function on this side will do something like this. And then on this side, I know what it's doing towards this. It's probably going to go down, but I just want to make sure it doesn't cross the horizontal asymptote. So I'll plug in like 1, 2, 3, 4, 5. So if I substitute in 5, I have 5 over 5 plus 1, which is 5 over 6. So it is on this side. And I can draw my graph. Cool. That's all there is to it. Let's do another. Pause. We are going to be doing the same thing here, so go ahead and take a second. Pause the video. Write down the problem. Try it before you buy it, because we know that's how mistakes are made. Okay, and again, this one I noticed that the degree on top is lower than the degree on bottom, so my horizontal asymptote will be y equals 0, so do. For the vertical asymptote, if I take the bottom, set it to 0, and solve, x squared plus x minus 2 cannot equal to 0, because you can't divide by 0. You cannot divide by 0. Please do not ever divide by 0. X plus 2, x minus 1. Yeah, I can factor. I hope you can too. So I have x cannot equal negative 2, and x cannot equal 1. Cool, so negative 2, 1. So I'm going to have some funky graph.
Yeah, funky graph. I like funky graphs.
For your x-intercepts, 0 equals x over x squared plus x minus 2. Multiply by your denominator to get rid of it. And that'll still make 0. That makes 1. 0 equals x. Hey-oh, it crosses at 0. Ooh, but that's on my horizontal asymptote. Remember, sometimes you can pass your horizontal asymptote. But I don't know if this is going to go up this direction or it's going down this direction, so I'm going to have to pick some few points. But let's go ahead and do our y-intercept, get that out of the way. So with the y-intercept, if I substitute in 0 for all of my x's, I have t of 0 equals 0 over 0 squared plus 0 minus 2, which is 0, because 0 divided by anything is just 0. Just remember, you cannot divide by 0. Do not divide by 0. Okay, so for my y-intercept, well, hey-oh, that's the only time I'm going to cross the y-axis too, same as the x-intercept. Okay, now I got to figure out what is going on. So I'm going to pick the point, say like 2. So I'm going to make a t-chart off to the side here. Yay! X, Y. Pick 2. I'll pick 1, 2, 3, 4, 5. Oh, 5. So if I substitute in 2, I have 2 over 4 plus, that's it, 1/2. 5 over 30 minus 2, so 5 over 28. So it looks like 2, it's 1/2. 5 is 5 over 28. I'm going to check 2.5 just to make sure that goes up. Sometimes they go back down. So if I do 2.5, 2.5 squared is 5.25, I believe, plus that 7.25. So that's going to be going up. We are going to be positive. Un momento, I'm going to use a calculator. All right, and this came out as 0.37, so it went up just a little. Oh no. Oh, I did 2.5. Whoops. Hang on. I want to do 1.5. 1.5! Ah, you can see my mouse. Hello, mouse. Yeah. Sorry, because I wanted to know what happened between here, so I should have chosen 1.5. 2.5 is cool, but it doesn't help us. My bad. My B, yo. I know, I'm sorry. But it does go up, so I know on this side of my graph it will go something like that. It's getting closer and closer to the asymptotes. Now I'm going to check all of the points in between. So I'm just going to take a second so I don't waste your time. I'm going to pick some random points. I'm going to pick points in the middle here. So I'm going to choose, say, like 0.5 so that I can figure out what it does over here. And I will choose negative 1.5 so I can figure out what it does close to here. I will also choose negative 3 so I can figure out what it does there. And I will choose negative 5 so I can figure out over there. So I'm going to plug in these numbers. I will come out some values in here just a second, and we will put those points on there together. Hello, Huskies. Nice to meet you guys on the other side. So I plugged in 0.5. It was negative 0.4, so it's going to be down here. I plugged in negative 1.5. It is 1.2, so it's right there. So it looks like in between here, I almost have like a cubic type function. And on this other hand side, I have negative 3, negative 0.75. So negative 3, negative 0.75, negative 5, negative 0.27. So it will do something like a lot. And there would be our graph. A little bit complicated, but make sure you just take your time, plug in some points if you really don't know what's going on. You always, always, always need to find horizontal, vertical, x-intercept, y-intercept. Let's do another. All right, here we go. In this one, I noticed that I have a squared on the top, squared on the bottom. So when you have ones like these, don't forget about those things that we call holes, where we have discontinuities. And remember, the way that we find that is if we factor the top and we factor the bottom, if there's a factor in common, see how this x plus 1, we have it in common, that is going to have a hole at negative 1. So hole at x equals negative 1. It will kind of still look like it passes through that point, but it won't. So this is not actually one of your vertical asymptotes at negative 1, since I can essentially just divide these to make 1. The only vertical asymptote that I'm going to have in this situation is x equals 5. For my horizontal asymptote, I know that the power on top is the same as the power on the bottom. I have 1 over 1 as far as my coefficients go, so y equals 1 is my horizontal asymptote. For the x-intercepts, I'm only going to have x equals 3, so it is the zeros at the top. For the y-intercept, if I plug in 0 to everything, I will have negative 3/5. So I'll have the point 0, negative 3/5. So I'm going to take a second and put all of that on my graph real quick. Sorry, I thought about it. I'm actually going to walk you through this again. My bad. So horizontal asymptote, y equals 1. Put that on my graph. Vertical asymptote, x equals 5. 1, 2, 3, 4, 5. There's our vertical asymptote. X-intercept 3. So 1, 2, 3. There's my x-intercept. I should have made that in black. I apologize. Y-intercept 0, negative 3/5. Oh, negative divided by negative is positive. I apologize. Come on, think, Mr. Pike. Negative 3 over negative 5 if I plug in zeros for x's. Negative 3 divided by negative 5 is a positive 3/5. I apologize. Oh no, I got black all over my hand and now it looks bad. Oh. Well, on this side, I actually have a couple points, so I'm good there. Oh, and don't forget our hole at negative 1. So at negative 1, make sure you draw an open circle. It doesn't look very open. That circle right there is open. Open circle. Open circle at negative 1. That is what a hole is. You cannot actually have that point. If you were to look at your table, you have everything around negative 1, but you do not actually have that point at negative 1. It is undefined. Cool. Yay. Hole. If I plug in points over here, I promise you will get something like this. I trust that you guys can plug in x values and find y values.
No, I'm not ready.
Okay, now I think I can handle it. So with this one, if I think about my horizontal asymptote rules, the top degree is higher than the bottom degree, so going back to that is the one that I showed you that looked like that. Yay! So in this one, I'm going to have something called an oblique asymptote. And to find the oblique asymptote, we're going to use division like we'd see how. I'm just going to divide this polynomials, that's why we learned section 2.3, and ignore the remainder. So with this, I can do synthetic since I see I have a linear function on the bottom. I have 1, -4, 3. I can pull that down. I have 1, -4, -8. Oh, it doesn't even matter at this point, but I'm going to do it anyways, -29, because I'm going to ignore the remainder. So what I'm going to do, since I have no horizontal asymptote, but I do have y equals x minus 8, the function that is left over without the remainder, do not look at the remainder, that is my oblique asymptote. So I need to go a little bit lower on that graph. I have 1, 2, 3, 4, 5, 6. I can count. Yay, I win the game. You lose, but it's okay because you're not even able to compete. So if I just draw the line y equals x, that is an asymptote that I will not be able to cross. Cool. Now with my vertical asymptote, take the bottom, set it 0, just like you know how. So x cannot equal -4. So 1, 2, 3, 4. 4. I can count, I promise. I almost lost the game that time. Oh, but you lose the game if you talk about the game. And if you think about the game, you lose about the game. So everybody lost the game. It's okay. Silly game I used to play in high school. You can't talk about the game. You can't think about the game, otherwise you lose the game. So it's just a matter of, I don't know. It never really made sense to me, so it's fun. X-intercepts. Take the top, set that to 0, and solve. So x squared plus 4x. It's not really that. It's minus 4x. I'm just changing the signs for fun. Not really. Don't change the signs. X will equal 0. This is x minus 3, x minus 1. So I'm going to cross at 3. I'm going to cross at 1. For your y-intercept, substitute zeros for all of the x values. We are left with 3/4. So we have the point 0, 3/4. Cool. 0, 3/4. I have 3. 1, 2, 3. I have 1. So my graph will get something like this on this side, which means it will be just the opposite down here. And plug in points, you will find that it is below your asymptotes down there. Cool. Playing asymptotes. Yay! And now it's time to party.
Oh, yeah. Oh, getting crazy. Oh, hanky panky.
Good boy, buddy. Oh, he's such a good trooper. Oh, I need my light. I hope that was enjoyable for you. I enjoyed it. Hank enjoyed it. Not really, but you'll see more of him. He will be a star. I will make him a movie star. Okay, if we are trying to solve something like this, first take a second. Remember, you cannot divide by 0, so you have to say in the beginning of this problem, x plus 3 cannot be equal to 0, so I know for sure that x can never equal -3 if that is ever a possibility. Okay, now we can take the time to actually solve it, so I could do plus 4, so then I would have 20 over x plus 3 equals 4, and then I could multiply both sides by x plus 3 to get rid of that fraction. So that will divide and make 1. And then I have 20 equals 4x plus 12. I can minus 12 to the other side, so I have 8 equals 4x, and x equals 2. It's not -3, so it is a good solution. Yay! Okay, same sort of deal. Again, take the time. If you don't take the time, you're going to make some mistakes. X minus 2 cannot equal 0 because you cannot divide by 0. So x cannot equal positive 2 ever, ever, ever. Now I can take the time and multiply this by x minus 2 on both sides, x minus 2, yay. So I have 9x equals 6x minus 12. I can subtract that 3x or 6x to the other side. So I have 3x equals -12, so x will equal -4. Good solution. Okay, now we have one that takes a little bit more time, it's a little bit more involved, but it's still not too terrible, so I love it. So with this one, I know I cannot have x not is equal to -3. X cannot be 6. If you were to factor out the bottom of this, you would notice that it has the same factors as these, so I have listed out everything that I cannot have in the beginning. Now in order to add these, remember to add fractions you have to have a common denominator, so I'm going to multiply this one by x minus 6 over x minus 6. I'm going to multiply this one by x plus 3 over x plus 3. And now I will come out with 2x squared minus 12x over x squared minus 3x minus 18 plus 3x plus 9 over the same thing, x squared minus 3x minus 18 equals 27 over the same thing, x squared minus 3x minus 18. Cool. Now if I multiply, notice all these are the same. So if I multiply both sides by x squared minus 3x minus 18, makes 1. Same thing over here. Multiply by the x squared minus blah, 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 minus 18 minus 3x minus 18. Makes 1 and makes 1 with both of those denominators. So really I'm left with 2x squared minus 12x plus 3x plus 9 equals 27. And then it's just like regular quadratic. So 2x squared was that minus 9x minus the 27 to the other side, so minus 18. I do hope and pray. Yes, sir, that is correct. Hopefully this will factor. I'm going to take a second and factor it. And there's our factorization. Yay. Yay. You can multiply it out if you don't believe me. 2x plus 3 equals 0. So x would equal negative 3 over 2. And x equals 6. But don't forget from our original solutions, x cannot equal 6. So no bueno. That is not a solution. I only have one solution. In this case, I have negative 3 over 2. Oh no, I marked on the desk. Oh no, it's so ugly. Will it go away? Yay. Okay, now go practice these things that we have talked about. Keep in mind that I'm always here for tutoring. Please ask me questions. If you don't do well on a test or a quiz and you haven't asked me questions, I'm sorry, but I don't feel any sympathy. You gotta ask me questions. You gotta try the work. Okay, use these examples to help you with your homework. Yay! Love you guys. Bye-bye!